A polynomial is the sum of a finite number of terms of the form ax to the n, where a is an element of the real numbers and n is an element of the whole numbers. Now that definition may seem a bit confusing at first glance, but actually, once you see a few examples of what is and what is not a polynomial, you see that that's actually a pretty simple definition, and that polynomials are among the easier expressions to work with. First of all, an example of what is. 5x is a polynomial because 5 is a real number, and this x is being raised to the first power. 5x to the 1/2 is not a polynomial because the 1/2 power is not a whole number. A 3/8 x minus 4 is a polynomial because we're dealing with nothing but real numbers, and again, nothing but the first power. If I had a 3x squared minus 5x to the negative 2 plus 7, that would not be a polynomial. Not because of this first part, that's okay. Not because of the last part, that's okay. It's this negative 2 power. In a polynomial, your powers are going to be whole numbers. Specifically, that means that the variable, usually x, but not always x, but the variable is always going to be raised to the 0 power, as in showing up as a constant, first power, second power, third, fourth, fifth, and so on. No negative powers, no fractional powers, and something else you won't see. You might see something like 8x to the third minus 4x squared plus 11. You'll see higher powers, third and up. But another thing you won't see is a variable in a denominator. Even though this first part, again, like it was before, does not prevent that from being a polynomial, a variable in a denominator implies that you're dealing with a negative power, and negative powers, again, are not allowed. Now, there are 2 or 3 types of polynomial expressions that are going to be given more specific names. The prefix mono means 1. So a monomial is nothing more than a polynomial that only contains one term. Examples would be a constant. That's an example of a monomial. A negative 7x would be a monomial. A 2x would be a monomial. A negative 11x squared would be a monomial. A 3x to the 7th would be a monomial. Bi is a prefix that means 2. So a binomial will have 2 terms. 3x plus 5 is a binomial. Here's your 1, 2 terms. Again, terms are separated from one another by addition. So, another example would be a 6x squared minus 3x. That would be a binomial. Here's your 1, 2 terms. A 4x to the 7th plus 2 would be a binomial. Here's your 1, 2 terms. Tri is a prefix that means 3. So a trinomial would be stuff like 2x squared plus 3x plus 5 would be a trinomial. 4x to the 5th minus 3x to the 4th plus 11 would also be a trinomial. Here's your 1, 2, 3 terms. Now, every monomial is going to have a degree. When we're dealing with only one variable in a polynomial, the degree is pretty easy to see. For example, 7 is a monomial, and the degree is considered to be 0 because it has an imagined x to the 0th power on it. This next monomial was degree 1 because this x is the first power. Down here we see a degree 2 because the highest power here is second power. Here's a degree 7 because of the power. Now this binomial is degree 1. It has a degree 1 term and a degree 0 term. You take the higher. This binomial is degree 2. It has a degree 2, a degree 1. You take the higher. Over here, this trinomial, what degree would it be? Well, it would be considered to be degree 5, because it has a 5th degree, a 4th, and a 0. You take the highest of the 3, and that's the degree of the entire trinomial. Now that's easy enough to see when you're only dealing with one variable. A polynomial can work with more than one variable. For example, if I had a 3x squared y to the 5th plus a 4x squared y to the 6th minus an 11x to the 5th y to the 3rd, let's look at the degree of each term. This term has a power of 2 and a power of 5. We combine them, and we consider that to be 7th degree. 6 and 2 is 8th degree. 5 and 3 would be 8th degree. So each term, one at a time, can be looked at to check its degree. And for the overall degree of the entire, and this one would be a trinomial, 1, 2, 3 terms, we would say that this is an 8th degree trinomial because that is the highest one there. Now, when you write a polynomial, there's a certain order in which it is supposed to be written. If I had 3x squared plus 4x to the 5th minus 7x to the 9th plus 12, that's not written in the proper order. Polynomials always have to be written in descending order, which means the negative 7x to the 9th needs to go first. The plus 4x to the 5th is after that. The plus 3x squared is after that. And the plus 12 is last. This is descending order, and this is always the order in which a polynomial should be written. It's not hard to do when you're dealing with one variable. With two variables, it can be a bit more challenging to get it in the correct order. But this is the order you'll always see your answers in the back of your book and on tests, etc. So this is the habit you need to form. Now we need to actually get into the actual addition and subtraction of polynomials. When you're adding a polynomial, you're simply going to add like terms. You've already seen a little bit about what it means to have like terms within an algebraic expression, but we need to go into that just a little bit deeper. Let's say we had a 5x plus 6, which is a binomial. To that we're going to add another binomial, a 2x plus 9. When we're adding polynomials, we are simply adding like terms. So in this particular example, I would add the 5x to the 2x, and I would get a 7x. Don't be tempted to call this 7x squared. Even though we have just dealt with exponents, the addition subtraction will not change your exponent. So we will go on and take the 6 and the 9. 6 and 9 will give you 15. So again, just a matter of combining like terms. And we know that x's are like x's. We know that y's are like y's. We know that constants can be added to constants. But when we get into the polynomials, there's a bit more to it than that. Let's add the trinomial, negative 5x squared plus 7x minus 9. Add to that a 4x squared plus 11. We're adding a trinomial to a binomial. Again, adding like terms. X's are like x's and y's are like y's, and x squares are like x squares. We'll add the negative 5 to the 4 and get a negative x squared, or negative 1x squared. 7x, there's nothing there to add to it, so it comes on over. The negative 9 and the 11 will give you a plus 2. Alright, so let's try a few more of those. Let's add an x squared y plus x minus y to a 2x squared y plus a 2x minus 6y plus 3. we're going to add a trinomial to a polynomial with 4 terms, which doesn't have a special name. X squared y and 2x squared y make 3x squared y, if you assume that to be a 1. And x and a 2x make a 3x. A minus y and a minus 6y make a minus 7y. There are no constants, so the 3 just comes on over. So x's will be added to x's, y's to y's, x squares to x squares, x squared y to x squared y. Now, one thing that you should not allow to confuse you, if I had a 3x to the 4th plus x cubed y squared plus 5, and I was going to add to that a 5x to the 3rd minus 6y squared x cubed plus 2. Let's see what we have. X to the 4th, there are no others, so it just comes on over. X to the 3rd, there are no others, so it just comes on over. X cubed y squared x cubed, are they the same? Well, the commutative property says that in fact they are. And x cubed, square on the y, square on the y, yes. Putting that together, I have a minus 5, and I'll put it back in the best order, which will be the x cubed y squared order, taking it back to alphabetical, and then 5 and 2 will give you 7. So again, with your addition, you're just going to combine like terms. And with subtraction, there's not much more to it than combining like terms again. Let's say I had 9x squared plus a 5x minus 3. And I want to subtract from that an 11x squared minus 2x plus 5. This minus sign in between acts like a negative 1 that's going to be distributed. So I'll have the 9x squared plus 5x minus 3 minus 11x squared, distributing the minus sign through, the minus 2x becomes a plus 2x, and then the minus 5. Combining like terms, negative 2x squared comes from here and here. 5x and 2x is plus a 7x. Minus 3 minus 5 is a minus 8. Clean that up a little bit. That was a minus 8 once we put it together. So again, with the subtraction, it's nothing more than the distributing of a minus through the second set of parentheses. Let's try another one, and we'll switch to another variable for a change. Negative 3a squared plus 2a minus 12. From that, we will subtract. And negative 4a squared minus 3. Lots of minuses here to emphasize what's going to happen. Negative 3a squared plus 2a minus 12 stays as is. This minus gets distributed. The minus 4a squared becomes a plus 4a squared. And then a minus on the minus makes a plus 3. Again, distributing the minus through as if it was a negative 1. The 3a squared, the negative 3a squared and the 4a makes an a squared, or 1a squared if you want to call it that. The 2a, there has nothing else there like it. The minus 12 and the plus 3 is a minus 9. So again, with the addition and subtraction of polynomials, you're really doing nothing more than combining like terms. And remember, your powers should not change. You should not add or subtract exponents for addition and subtraction of polynomials.